All right, so there's a lot of people here that are stuck on math and stuff. And this channel, I haven't really done a lot of things with math lately, unfortunately. I've been so focused on IT, I almost feel stupid because, you know, I'm not even in an area of IT where we're using electrical physics. I'm not. I'm not in an area of IT where we're using, um, you know, the type of logistical planning calculations, business calculations and stuff, and things related to the operational research aspect of it and stuff. Like this, I'm just studying the A plus certification. It's so like after you spend enough time away from doing math, you just start to feel dumb and stuff because math doesn't set a limit on on how much you want to think about something and express that thinking and stuff. Like it's the more thinking you put into it, where it, where you could produce more written work, typed, written, whatever, or drawn up, then the better quality it is, as long as everything's coherent and you're not just, you know, saying a bunch of random nonsense and stuff. Um, so yeah, let's. So what do you do when you're stuck in a hard math problem? Um, I have no idea when I got Rainbow Six Siege, I, but I did. That's weird. Let me see. I just need to see about this for a second. What's going on? Oh no, that's just something in the Microsoft store. I was like, what? I like. I mean, I loved Vegas and Vegas 2, but that's why I don't need Siege and stuff. I had enough of Vegas and Vegas 2. It's great stuff. It's just a little bit too like panicky and stuff because things get out of hand really quick when you can't just calm down and stuff. Um, it's kind of a game for jocks, unfortunately. And yeah, I know I play games for jocks like Space Marine 2, um, and I really love Doom Eternal and Halo and stuff and very jockey games. But damn, um, I it's just it gets a little bit too much because I you can only have so much of that stuff. Um, I had an excuse to play Space Marine 2 because of like it was just so good overall and stuff. Um, Vegas 2 and Siege, they're very nice, thoughtful games and stuff, but the story is just like, uh, should I really be paying attention to this and stuff? It's just a little bit. I don't think it's good for civilians to play unless they're poolies. You know, I just, uh, yeah, I read enough of the news, and it's very overwhelming. Well, some of the time at least. Just lately, I mean, I just like Space Marine 2 better because 40K is like more straight up about reality without really being straight up. Um, I just need a second. All right, so that was annoying, and um, where? Okay, let's go to the really hard stuff because this is where people usually get stuck. The easier math problems, just require you to think of less and ask for less, and they might even be multiple choice to make it easier and stuff. 50 hardest SAT math. That's funny. The idea of the SAT being, or the SAT is time consuming and stuff, because you have to look at that whole world, but it's not hard. Um, SAT 2 math. No, let's look at. Um, no, let's differential equations. I mean, oh, this is real analysis. Yeah, I mean, this is an example of like the harder stuff. This is like the mid-range for the hard level stuff. You know, it's like 300, 400 level stuff. It's just hard for me to think of where I would find a harder problem right now. Homework in this finds midterm practice. Okay, let's look at this midterm practice here. Okay, they're not saying much, but they are saying a lot and stuff. See, and this is where people get trapped a lot and stuff. When they say a bounded function and stuff, you're talking about not just one relation, but multiple relations. And the rules change because the meaning, because the meaning of the characters change sometimes with respect to this field. Like this f here and stuff, it's not necessarily a quantitative function and stuff. It can also be an operation. So you have to know that. And for this type of math, you know, I mean, this is basically the same. This right here. R is thankfully always the real numbers. Anybody who makes it something else without indicating is doing things wrong. Thankfully. Yeah, so in math work, like you want to leave away the mindset of consensus and other direct mindset experience and stuff. You want to think of like not like internal values, but like the literacy-based mindset of like what this canonically means and stuff. And you know, you might have to support your answer with references too. So that should help you. And convergent subsequence. Okay, so you might think of this pictorially or verbally and stuff. That's some of it, and that helps. You don't want to drop that. As long as that's justified, you want to keep that in your understanding of the problem. But you also want to understand this has a mathematical implication too. So true or false divergent sequence can have a convergent subsequence and stuff. This might be a test of like your knowledge of the field and stuff, but that's not necessarily what a book said. It has to be based off of like the more fundamental axioms and claims. Like premises become conclusions, treated as premises, which follow up to premises and premises and stuff. And then your conclusion is basically, okay, have you solved this? Have you evaluated or proven this and stuff? And supremums. Supremum infimum states a definition of supremum set A. Okay, so we have the supremum and stuff. That's going to be based off, that's going to refer to a certain property and stuff, which is mathematically expressed and stuff. Then you have A says sub R. I'm a little bit foggy in the notation here, but I'm pretty sure that this is A within R, but not necessarily the same as the totality of R. And there exists A. So yeah, like understanding these little characters here, but you have to like interpret it in terms of a mathematical construct. Like, is it a diagram? Is it a relation, like an equation with a string of mathematical information and stuff? Is it words? If it's words, what does it translate to and stuff? Because, you know, we're not over here to potentially, like, I don't think there's a real, like, grounded internal rational reason for it other than you have to demonstrate your level of mathematical skill and competence, because this is part of a whole industry, like a whole economy of, okay, you're doing this for a research paper and stuff that might be used for something else, you're doing this for a grade, you're doing this for your skills and stuff and everything because, you know, you're going to a mathematics intensive job, or you just love mathematics, I mean, which was mainly the reason why I did it, or, you know, you're becoming a professor and stuff, and you just need a good background in mathematics because they might need you to teach a mathematics course and stuff, or you just, you know, you're making yourself smarter and stuff. I basically studied math for all of those reasons. Honestly, I was a lot dumber a lot more of the time before I studied math. I thought I knew a lot of things and stuff because I could read a few textbooks. But then I learned quickly that, you know, there's not just things you have to learn, but there's thinking skills and there's, you know, there's capacities, and you have to, you know, think about how long you can do something for and stuff. And so yeah, and now I'm the mess you see here. So, but this has nothing. But you know, enough jokes and lighthearted talk is probably not constructive. Yeah, you know, Okay, so here, we have a network of interrelated relations and concepts and stuff, and then it goes, then the supremum subscript. So, because it's subscript, you can say that this is an index and stuff, like something from the set of n. Is probably safe. Though, if it doesn't give you a coherent result, it's probably ended up wasting time, honestly. um, and then what's called it? Okay, so when it says, when you have like a full period and then and stuff, is basically saying like that's a consequence of all of this. If you try to take it verbally and stuff, you're going to be lost. You have to take it conceptually, mathematically, and you have to use reasoning, problem solving and stuff. Like you have to like actually have an intelligent thought process going to do this. And you could have a ton of thoughts and stuff, but if you're going to skip steps without showing that you've done the thinking and stuff, you might not see the points here. So, I mean, for something like this, I would just attach a piece of scrap paper and stuff and write down your answers here, and you can write notes for your teacher here, like, okay, see, justification for answer and stuff, because, you might find that, something's expected to be true when it's actually false and stuff. But the thing with mathematics and stuff, you don't just have true or false, you also have correct or incorrect and stuff. They might want something that's correct and true and stuff because the priorities are different and stuff. Or something that's correct but false and stuff because of, like, and, I mean, it's because I guess that area of the theory has not been fully developed yet, and you don't have the time to really develop the theory, basically. That's a good way of looking at it and stuff. But maybe that's my more game theory influence mindset and stuff. Game theorists don't rule the roost and stuff. They just don't. SL1, SL2, slide 1 and slide. This is funny. Cauchy sequence. Say the definition of a Cauchy sequence in R and stuff. Did you study the textbook and stuff? Maybe you have a sequence in R, and so now you have to look at all possible sequences in R. Congratulations, because you didn't want to study Cauchy and stuff. See, this is where you have to know mathematical openings. It's basically, Okay, Cauchy sounds too much like Coochie, so I'm just gonna go to something else. I can't think about that right now. I mean, I should, but I'm not. Geez. God, I miss your mother. So, that's Google's probably not the place to ask this. I'm just gonna go to maybe something like All the Internet, Get Better Search Suite. Oh no, not this, not this. Bam. This is what we need. Hardest SAT math questions ever. Okay, let's give this a try here. It's like this is just conversion of Fahrenheit to Celsius. Anyway, so realistic temperature, blah blah blah. By the way, you don't want to read out loud during an exam or a midterm and stuff. In many schools, they can just straight up cut your points or disqualify you. You want your professor to be happy with you and stuff like that, and to like you. The last thing you want to do is argue with or offend your professor. That's basically a death sentence. Professors aren't bad people. They're there to teach you and stuff. You just have to be willing to crack open that cooler that might be ice cold, blast you in the fucking eyeballs and stuff. And, to reach in and get that delicious drink of knowledge and stuff. You can take that sexually, I don't care. So, it's called, one is think of the equation for a line, y equals mx plus b. Wait, are they throwing y equals mx plus b at me? Come on, this is from the 9th grade of high school. Anyway, this equation, here we go. So this is rather long and stuff. This might get some people. So the equations, are you willing to work with the pieces and not create pieces that aren't there? That's what you have to do for a lot of this here. It's true for all values of x. That's understood as a mathematical string of information in your head. If you don't have that mathematical string in your head, you're in the wrong idea and stuff. Not the wrong idea, but like it's like you have to understand the meaning of it. That's the thing. Like the mathematical string is just one part of the meaning. The rest is the figure and stuff. And and then there's the figure, and then there's the what's it called, the form-based understanding, meaning the understanding that is, you know, based on mathematical expressions, just analytical expressions, the numbers and symbols and everything that are spit out and stuff as a result of the input and output and stuff, because these operators, you know, these pluses, these minuses, the divisions and stuff, are doing things to these quantities and stuff, which creates at least one accurate or correct figure. Okay? So it's still theoretically consistent and stuff, as long as the notation is good and stuff. Once you start creating contradictions and stuff, then, you know, you basically are not masking, but like you're that's basically like the computer programming area of math and stuff. And that's I guess it kind of goes back to what I said, how different fields use the language differently. There's multiple mathematical senses to each character, you know, and you know, the more you know about that, the better you are at it and stuff. Sometimes you need something harder to get better. And I apologize to any ladies I offend or disturb with that one. Because anyway, so there are twins in AX. You should have multiplied using FOIL and blah blah blah. Okay, so here I mean, these methods work. They work. They get you points and stuff. All that matters is that you show readable, clear work that leads to the correct answer. And like when you're dealing with multiple choice, you know, you just have to pick as close as possible the most correct answer and stuff. Not all your answers will be correct. You pick the most correct one, and then you could even compare it to the other ones. You know, why might it be something else? Like, what is missing about this meaning of this question? You know, yeah. So, here we go. Millennium Prize problems. Here we go. This, you know, the stuff that people say is scary and difficult. I mean, these problems are always the same and stuff. It's like generally the same. It's just more math.
It gets.
Here we go.
It gets infinite very.
Take loops, primes, blah blah blah, stuff. You know, the trick is to assign as much meaning to it as possible before you start getting this conceptual fat in the idea. So yeah, you have to use your introspective visualizing mind and stuff, and it has to be backed with, you know, mathematical research and stuff. There's key books you got to study, like the Grundlagen der Mathematik, meaning the Foundations of Mathematics by David Hilbert, Euclid's Elements, the books written by you know, Isaac Newton's Optics, and then, you know, of course the newer books as well, like stuff from like what's it called, you know, John von Neumann's books and stuff like that. You know, just those foundational books from not just highly respected mathematicians, but like from people, like books that really show you that things are correct. Basically, you know, you can read Ramanujan's books if you want and stuff. He wasn't really explicit. Euler's books and stuff, as Euler, however you want to pronounce it. Who else? Aryabhata and stuff from, you know, the ancient Indus Valley. Um, uh, yeah, basically the books from mathematicians that wrote stuff, and then there's like some books from mathematicians that you know knew computer programming and stuff, and knew could do computational solutions on the computer and stuff. That's not really for exams. That's more for projects and stuff. For an exam, you want to know the concepts, and you might need to, but there's a small chance you might need to program to show the skill. If it's a take-home exam, you don't want to dally with that one. But yeah, so like if you're stuck on a hard math problem, here's some thoughts that those definitely some thoughts that'll help you. And I guess we got to give more attention to this right here. Equals infinity. See, this is very interesting because m and so as m, in the simple case, in the simple consideration and stuff, as m gets large and stuff, this whole thing actually should be getting smaller, but it's infinite and stuff. Not just because the magnitude of the figure is infinite, but because look at this, you have m equals 1, and then this goes infinity and stuff, and then we have this function right here and stuff. This right here is a character you have to dig online for and stuff and find out and stuff. And so, which explains the meaning of this function here. We have this function. This is not a comma. Again, this is a 1, and so that can throw you off sometimes for a second because of the way that it is written. But so we have this function here. This this squiggle. Where if you input a 1 or an I and stuff, you get this series and stuff. That series is the evaluation of that function and stuff. So you have to go not just the fundamentals of a function and stuff, but go to, the other implications of material or personnel doing something or having a, some kind of modality and stuff, and that can cause quantities and stuff. So it's pretty general and stuff. And then we have take logs. You take the logarithms of this, and then you get this, right? So, which is interesting. I think this is his finished work here. So maybe there's an original form of the problem. He did some work on the problem and stuff. I don't think he solved it.
As historical and elementary as I can be in describing the problems. Well, does that cover it? Yeah, okay. So we begin again with the primes. Every number bigger than 1, as you see here. And he used that fact to prove that this sequence never stops. If it did, if there were only a finite number, you could multiply them together and add 1, and you would have a number that was divisible, bigger than 1, which is divisible by no prime, and that would contradict the fact that...
When we're trying to say something is something in mathematics, most of the time and stuff, and I'll go into the most aspect of it in a second. Most of the time and stuff, we just understand the evaluation of a property and stuff. We're not thinking of the encapsulation of the whole thing. We're just looking at what's important and stuff because of the mathematical continuations that can follow and stuff. Now going where I was talking about most of the time, it's not always a linear scale. You have to have a sharp mindset of understand the difference between the cases and stuff. Not just noticing that the cases are different and stuff, but interpreting them and using your mathematical literacy and skills on them and willing to see the process through and stuff. Even if it means you take at least one break. And yeah.
Every number is a product of primes. So Euclid never did state that
he said every number is a product of primes and stuff. That can you know, when we're proving it, we don't care about whether it's true or not and stuff. We're applying a valid proof to it and stuff because we know it can be true or not true based off of where in the figure you're looking at and stuff. Only the important parts of the figure of our concern and stuff. Why? Because again, mathematics is a thinking system and a writing system for like I said before, isolating the important stuff from the not important stuff. Because not everything is automatically important at once. It's just not. It's just not. It can't be and stuff. Or at least most of the time it isn't. When it is, that's what we have computing for and machines for, and certain people. Not everyone's an information handler. That's just how it is. So there you go. Want to know a limitation in mathematics? There you go. And that's the reason to go into applied mathematics, I guess, and stuff. But yeah, so I mean, that's all I can say about difficult math problems if you're stuck on them for now. And so I didn't want to ignore the topic of math.